Okay, so when we ran out of time, I was talking about what do you need to make current flow? You need a material that it'll flow in, like a conductor. You need something that's creating a difference in potential in the circuit, which is what this battery's doing. The battery's making one side of the circuit have more potential than the other. And then you need a closed circuit so it'll flow, the current will be able to flow through it. Now, what I didn't talk about up here when I was talking about current is something that I mentioned the other day, and that is back in the beginning, years and years ago, people just assumed it would be positive charge flowing, just because, of course it would. When we eventually figured out the structure of the atom, so we're talking like 1908 to 1920, they realized that there's no way it could be positive charge flowing in a wire. It has to be negative charge because of where the electrons are located. The electrons are located outside of the atom, on the edge of the atom, and it's really easy to take electrons off. I can rub my fingers together and remove electrons from my fingers. It's much more complicated to move protons. They're stuck inside the nucleus. So, but once they figured that out, they were like, but man, we've based everything. We've based the direction of our electric fields. We've on the fact that it's positive charge flowing. So they didn't change anything. They hoped, they were like, let's not tell anybody, and maybe they won't notice. But of course, it didn't take long once everybody else heard about the structure of the atom that people started to say, okay, wait, it can't be negative, it can't be positive charge flowing if the protons are inside the nucleus. So to this day, you will see that there are people that use what is called conventional current. And conventional current means positive charge flowing. And electricians often use this. There are also people that use electron current, which name kind of speaks for itself. That assumes it's negative charge flowing. In the end, it doesn't change the math whatsoever. Okay, I tend to always use negative charge, which means my current will usually come from the short side of the battery. But your textbook, the Physics 12 textbook, and the Science 12.2 textbook, the Science 12.2 textbook always uses positive. The physics textbook oscillates a little. We will use both. And we will use both so that when you go away from me off into the big scary world without me, it will not matter who you run into in the world, what prof you have, whichever way they do it, you'll be able to handle it. When we get into hand rules then, if we use conventional current, it's our right hand. And if we use electron current, it'll be our left hand. So you'll become ambidextrous in hand rules. But don't worry, I'll tell you that when we get to the hand rules again. But for right now, just know that if it's positive charge flowing, it would leave from the positive side, go around through the resistor and back to the negative side. And you can think about the battery as like a chairlift on a ski hill. So the battery's doing work on the electrons, right? Down here's the positive side. It's doing work on the electrons to get them up here, where of course they don't want to go. So the difference in potential is between here. Once you get the electron up here, it's like, I don't want to be here. Just like you're at the top of the ski hill and you have all this energy, things always move to the lower point of energy. So you'll come down the hill, the electron will flow around the circuit and get back to the bottom of the battery. The battery will do work on it again, move it to the negative side, it'll flow around again. Okay? So what do you need for current to flow? Something that will put the electron in a state of high potential energy, and then it'll flow to the lowest. Just like everything else in our world goes from high energy to low energy, including you, which is why as soon as you get home you lay down on the couch or on your bed. Okay? So, and if we were doing conventional current, it would be the same thing. It's just the positive would be up here, the negative would be down here, and we'd be imagining the battery doing work on the positive charge to get it up here, and it would flow around. Okay, so it doesn't really matter if it's conventional current or electron, but we know the electron's the right one. When we build a circuit, then, We need a material through which current could flow. We need a difference in potential. We also need something that's going to use the energy the electron's carrying, something like a resistor. And I think in grade 9 science, you would have learned about resistors. The symbol is with the teeth. And this could be your microwave, it might be a light bulb, it might be your computer. We can make current flow if there's no resistor. I could take a wire and just hook it across the battery, and current will flow, but it'll soon burn out the battery. It'll blow the battery. It's called short-circuiting the battery. So you don't want to do that in a real circuit. So if you're building a circuit, you need something that's a resistance or a load, and then you need the battery, and you need the material through which it will flow. Now, if we wanted to figure out how much current was flowing here, we could use an instrument called an ammeter. And an ammeter is a meter which measures the amps. Its symbol is a circle with an A. And if we put it in the circuit, and we usually always put it in what's called series with the circuit, it'll read the current flowing through here. There's also something called a voltmeter. Its name kind of gives it away too. It's a meter that measures the voltage of the circuit, and its symbol is a circle with a V. Okay, maybe one other thing we need to talk about is how we hook up. Oh, I guess I forgot one thing. Two other things we need to talk about. One is the equation that you would have learned in grade 9 science. It's called Ohm's law. Ohm's law. And it's the thing that connects the voltage of the battery, the current flowing through it, and the resistance in the circuit. Okay, so if you have a resistor, you have a power supply, and obviously you have some current flowing here, there's going to be a connection. The bigger the voltage, the bigger the current should go in it for a given resistor. The bigger the resistor for a given voltage, the smaller the current that'll be going through. Ohm's law is very simply V equals IR. So the bigger the voltage for a given resistor, the bigger the current. The bigger the resistor for a given voltage, the smaller the current, right? So if I have a light bulb here, it will have a lot more current flowing through it than a microwave oven at a given voltage, because there'd be more resistance in a microwave oven. Okay? Voltage is measured in volts, and current is measured in amps. And so if we rearrange this, R is equal to V over I, so it means resistance is measured in volts over amps, which we rename an ohm for Ohm's law. And the symbol for ohm is the Greek letter, the capital omega. And I always think it's a stick man that's bow-legged and bending over. Okay, so that's an ohm. And this is known as Ohm's law. Now the one last thing would be, most circuits don't just have one resistor. Most circuits have more than one resistor connected together. So like in your house, you might have all of your electrical outlets on the same circuit. Okay, if they're connected like this is called a series circuit. And in a series circuit, all of the current flows through the first one, all of the current flows through the second one, and back to the battery. The other option for the way they could be connected is something like this. And when you see them connected like this is called parallel. Not because they're parallel to each other. Parallel circuit is, it has a junction. So the current comes up here, but then it needs to make a choice. Some will flow this way through R1, the rest will come up and flow through R2, and then they come back together here, and they come back to the power supply. So throughout this course, you'll sometimes encounter some talking about a series circuit or a parallel circuit. In Physics 12, we'll do the math for it. I just want you to be used to the concept. So series, one path, parallel, multiple